Hey, hello there. So today's Leetcode challenge question is called K's smallest element in a binary search tree. So we have a root node to a binary search tree. We need to traverse in this tree to find a K's smallest element inside this binary search tree. So since the tree is binary search tree, if we perform in-order traversal on this binary search tree, the values that coming out are going to be in the sorted order. So we can just do in-order traversal after we have looked at the k nodes value, exactly k, then that very last number we look at is the value that we want to return. Yeah, so the algorithm is just in-order traversal. While we process when we process the case node, we just return that value. That's pretty much it. In terms of time and space complexity, the average case, if the tree is totally balanced, I think the space, the time is roughly the height of the tree plus 3 plus k. In the worst case, the height of the tree is the total number of nodes. We have to at least go through all the nodes. That's when the tree is like only have left child for every node. So it's just a sequence. It's just a line, and we have to go all the way down there through all the nodes, and then backtracking k times. So it's n plus k. But on average, I think it's h plus k, the height of the tree. For space, for the worst case, it's the total number of nodes. So I would just say this is a linear in time and space if we do in-order traversal. So let's just code this up. It's really simple, this question. Yeah, so we're just gonna have a stack of tree nodes. Just call it toe, and we have a traversal node, which initially is the root node that we are starting our toe. The condition is that while the toe is not ended, we haven't ended the toe, or we actually have the traversal node, then we should resume this. The in-order traversal is basically, if we look at node 3, we want to explore the left descendants. After we process all the left descendants, we look at the node's value. So we would 1, 2, 3. After the node itself, we will look into the right descendants before we go back to its parent. So it's we always want to visit the left child first. So while we still have a node, we want to move to the left as much as possible. So that's this. And in order to be able to remember to what node we have to go backtrack to, we push this traversal node onto this stack. So that is, we reach as far as possible in the left descendants. Then what we do is just popping out a node from the stack. And that node is going to be the node we will read the value from. And so for every time we actually pop up this node, we will try to decrement this k. If it's become 0, the k value becomes 0, that means we are currently looking at the k's node in this sorted order. We just return this node's value. Otherwise, we would basically we read out the value, and we want to go to continue to explore the right descendants. So we do so by moving the traversal node to the right descendant, right child. So that's pretty much the code. I guess for the case when the tree is empty, or some other cases, by default we should return an integer. So just return maybe like a -1, something error that happened in between, I guess. So that's pretty much the code. And overall, it's a pretty simple question. If you know the in-order traversal, then this is really just applying that and early stopping when you process the k nodes. So pretty simple question. That's it for today.